Hello students, today we will be working on part 2 of our Honors Geometry Summer Packet, Systems of Equations. A system of equations is just a situation in which we have two equations and two unknown variables. In our cases, we have x's and we have y's. To figure out the x's and the y's, we have to employ one of two main methods. The first one we could use is substitution. The goal for substitution is to plug one equation into another. So first you look at your variables and you try to figure out which one is the easiest one to get by itself, the easiest one to isolate. You want to avoid making fractions or decimals if you can. In this case, this y has no coefficients, so that's going to be the variable that I get by itself. To get it by itself, I'll subtract the 4x from both sides. Now I'll begin the process of substitution. I'm going to take this piece and plug it in for y in my top equation, because that's the equation that I didn't manipulate. I can't plug it into the second one because it's technically the same equation. Whenever you plug it in, make sure that you put it in parentheses. Now it's a normal solving equation. I'll use the distributive property. So I have 2x plus 3 times negative 4x, so that's negative 12x. 3 times negative 20 is negative 60 equals negative 10. I'll combine these two guys together. 2x plus negative 12x makes negative 10x minus 60 equals negative 10. I'll add the 60 to the other side. And I have negative 10x equals 50. Then I will divide both sides by 10, by negative 10. So x gives me negative 5. That's only half of my answer. I need to figure out what y would be. To figure out y, I'll just take this answer for x and plug it in. I can plug it into this equation, or this one. Whichever one I use, I should end up with the same answer. I'm going to pick this one because y is already by itself. It'll be the easiest one to solve. So negative 4 times negative 5 is positive 20. 20 minus 20 is 0. And so the value of x is negative 5. The value of y is 0. Depending on your directions and your situation, sometimes you'll write it as an ordered pair. And that is the substitution method. Now let's work on elimination. Think about the word eliminate. When you're eliminating, you're trying to get rid of a variable. I often think that elimination is a little bit faster than substitution, but it does require a little bit of outside the box thinking. So looking at these two equations, this is the same example as before, but we're going to apply the elimination method. You want to pick a variable to get rid of. It honestly doesn't matter which one you use. The goal is that the coefficients of the variable you're choosing have to end up being the same. So if I want to eliminate the y's, I can very easily make the coefficient of this y be 3 by multiplying it and every other term in the equation by 3. I actually am going to multiply it by negative 3 because when I combine the two equations together, I need the coefficients to be opposite. So I'll distribute the negative 3. Negative 3 times 4x is negative 12x. Negative 3 times y is negative 3y. And negative 3 times negative 20 is positive 60. I'm going to go ahead and just rewrite the top one. Whenever you're doing elimination, it's important that your variables all line up. So you have your x's in one column, your y's in another, and then your constants in another. Now, I'm going to add the two equations together. So 2x minus 12x would be negative 10x. Positive 3y minus 3y is just 0, so I don't need to worry about that anymore. And then negative 10 plus 60 is positive 50. And then I divide both sides by 10 by negative 10. And so x is negative 5, just like before. And again, Take this -5, you can plug it in wherever you want. You can plug it in here, or here, or here, or here. You'll get the same answer. I'll plug it into the first equation. So 2 times -5 plus 3y equals -10. We have -10 plus 3y equals -10. I'll add the 10 to both sides. So they cancel from here. -10 plus 10 is 0. I'm going to divide both sides by 3. Y still equals 0. Now let's apply our knowledge of systems of equations to a word problem. The theater club sells adult and student tickets for the school play. On the first night, they sold 10 adult tickets and 10 student tickets and made $80. On the second night, they sold 21 adult tickets and 15 student tickets for a total of $150. What is the price of adult and student tickets? We can use substitution or elimination to figure this out, but first we have to set up our equations. We have two different things that we're trying to figure out: the adult tickets, the price of an adult ticket, and the price of a student ticket, which I will represent by A and S. So since I sold 10 adult tickets on the first night, I'll say 10 times the value of A, the price of a ticket, plus 10 times the value of S has to equal $80. That would be for my first night's sales. For my second night's sales, I use the second sentence, 21 adult tickets, so 21 times A, plus 15 times S equals 150. And I can do substitution or elimination to figure this out. Many of you are probably more comfortable with substitution, but elimination, again, I feel is a lot faster. Because if I look at my S variables, I can very easily make both 10 and 15 30. I'll multiply the top equation by 3, and I'll multiply the bottom equation by 2. One of the equations needs to be negative. It doesn't matter which one. I'll go with the second one. So when I distribute the 3 to the top, I end up with 30A plus 30S equals 240. And then for my second one, I have -2 times 21, so that would be -42A plus -30S equals -300. Don't worry that the numbers on the bottom are negative and that those numbers are bigger. Everything works out in the end. So now I add the two equations together. 30 plus -42 gives me -12A. They cancel here because positive 30 plus -30 is 0. And then -300, and I add 240 onto that, so I end up with -60. Divide both sides by -12. So A equals 5. So the price of an adult ticket is $5. Now let's figure out the price of a student ticket. I can use the 5 and plug it into any equation I want. I will plug it into the top one just because the numbers are a little bit easier to work with for the top one. So 10 times 5 plus 10 times S equals 80. So we have 50 plus 10S equals 80. I'll subtract the 50 to the other side of the equation. So 10 times S equals 30. When I divide both sides by 10, S ends up being 3, or the cost of a student ticket is $3. Use these examples to help you work on your own problems in your summer bracket.